a lot of developers at Wix, they need database help. Like a lot of other developers, they need help with data modeling, they need help with query performance, and a lot of other database stuff. Now, because we're only about like 5 people, you can think that we have quite a big backlog. So we thought a bit. How can we help them be a bit more independent? How can we help them finish the application a bit faster? How can we help them deploy to production even faster? Now, searching a bit around the web, also talking to the Oracle guys, we stumbled upon XDevApi, and here in the talk, I'm going to talk to you a bit about exactly what XDevApi, how can it help relieve the tension from the database administrators and give a bit more independence to the developers, not needing the database administrators for regular tasks that they usually do. So my name is Lior Altarescu. I'm a senior DBA here at Wix for more than 7 years. Worked with many databases through the years. The databases that I mostly focus on at Wix are MySQL and MongoDB. We have others, but these are our 2 main databases. Also do a bit of code, sysadmin, a bit of DevOps works, and other stuff, a bit what is needed. Now, in my talk, we're going to talk a bit exactly what is XDevApi, and how NoSQL and SQL can work together in a single database. We're going to show a bit of CRUD operation examples, and we're going to share our overall experience with XDevApi, how we're thinking of implementing it here in Wix, and our general impression of it. Wix is as I said before, Wix is a pretty big company. There's a lot of developers. Most of the developers like to work with unstructured data. For those of you who are not familiar, basically when we talk about unstructured data, we're talking about JSON. We're talking about JSON data types. So mostly developers, they don't really like to think about data modeling. They like to think, at least here at Wix, like to think simple things. We want to keep it simple. Now, also, we don't really have a lot of constraints. We don't really have many joins. We try to keep the applications as simple as possible. And also, one of the ways to do that is to have a bit more complexity in a simple system is also using JSON data types. Now, Wix has over about 130 million sites, even I think more by now. So usually when a developer comes and try to model their data, they would come with something like this, something unstructured. And when they come to us, the DBAs, when we think of the data and how the data looks through our eyes, we like to see structured data. We like to see connections, we like to see constraints. So there's a bit of a conflict between what the developer wants and needs and what is really ideal for really big scale like we have here at Wix. So the conundrum is, how can we also satisfy the developer and also make our lives easier? How can we work with NoSQL and yet also work in a SQL environment and maintain everything in a really nice and neat way? I hope that showing you this presentation here today, you'll also see that MySQL can help with this. MySQL can help and also save NoSQL data, unstructured data in the MySQL itself. And we'll show a bit how easily we can work with it in a very native way. So, what exactly is XDevApi? XDevApi is basically a high-level API that wraps around it smaller other APIs. With this, we don't have to think about tables. We don't have to think about triggers, other database objects. The only thing that we have to work with is whatever we want. We can work with in a schemaless fashion. We can input whatever we want, and we have a lot of space to store it. I'll show it in a minute. XDevApi basically gives us the freedom to work in the way that we're most comfortable with a schemaless fashion. But it also has a small catch. It also has can work with regular SQL. Talk about it a bit later. Now, the current MySQL connector is synchronous, but the new MySQL connectors that support XDevApi are asynchronous. They support CRUD operations. The way that they're asynchronous is they utilize callbacks and promises. And in that way, they are asynchronous. Now, the new connectors come in a couple of languages. They're all listed here. At Wix, most of our applications are either in Java or in Node.js. So that's something really, really convenient for us. Now, we're going to see a couple of examples during this presentation. All of the examples are done with Node.js through the MySQL shell. And that's what I'm going to address later on when we get to the CRUD operation examples. Cool. Now, the XDevApi doesn't only give us the option to manage our data in a very convenient way. We can also use admin API, and with the session API, we can use it to administer the database. We can easily scale, we can easily add new nodes without having to sort to regular tactics as we did before, such as if we wanted to add another MySQL slave, we would have to have a special infrastructure or scripts to use InnoDB backup or copy the disk to a new server, copy it, and then add it with the new XDevApi in correlation with InnoDB cluster. We could very easily scale horizontally the MySQL cluster whenever we want. Now, if you think about it, it's pretty ideal, because if we combine it with other tools like auto-scaling groups in Amazon, we could use it to increase our cluster at peak hours and decrease our cluster in non-peak hours without having to use some sophisticated script or something like that, only utilizing XDevApi, session API, which is something very, very neat and very, very cool, in my opinion. Now, how does the XDevApi work? XDevApi, basically, it utilizes the document store, and the document store is basically just a wrapper for JSON data type in the MySQL, where inside the JSON lives all the unstructured data that we're inputting. Now, the document store is schemaless. As I was saying, you could store whatever data you want. You could work in a non-SQL way. It's fully ACID. It keeps data integrity. If you want, you can also use the XDevApi to run SQLs. You're not restricted to only working in the new way. For instance, if a couple of applications are inputting data to the MySQL, you're working in an XDevApi way. Another application is working with native MySQL connections. You need to access their data, no problem. You could do it from the XDevApi. You can run query, select whatever you need. So it's not limiting you. You could also work in the old fashion. Each document size could be roughly about 1 giga. And also, whenever using the document store, each document can be up to 1 giga. It's very secure. It has SSL or TLS from the beginning, from when you configure it, it works together with that. And a couple of other things that the document store works with. Now, what is the correlation between documents and collection? When we're working with XDevApi, we basically create collections, and inside the collections, we will store our database objects. So a collection can be one or more documents. And if we look inside the database, what we will see whenever we run the create collection command, we would see a table. That the table has 2 columns. One of the columns is a unique ID. There's a unique ID for each document. and the other column is a JSON data type. Now, each row basically is a document. Whenever we create a new document, we insert a new row to the table, and all the schemaless objects data that we insert will be stored inside the JSON data type. Now, also inside that JSON object will be stored the ID from the column in the same row. So we have the ID also as a column and also inside the JSON object. Okay, let's continue. So NoSQL and SQL in a single database. How does this look from the database engineer's point of view? Let's take a look. If we look at the old regular fashioned way, we would use probably a regular ODBC connector. We would connect to the MySQL backend through the regular port, which is 33060. Now, if we want to use the XDevApi, what we would do, first of all, we would have to install X plugin. X plugin is not installed by default in 5.7. It is installed by default in version 8. So remember, if you're using either the version, in 5.7, you either need to install it yourself, or in 8, you have it from the installation. Now, with the X plugin, we can utilize the X protocol. X protocol is based on Google portal buffers that basically allows us to communicate with the XDevApi format. And what's really nice here, what Oracle did, that's really, really nice, they took the Google portal buffers, which is an open source project, and you can download it and you can add your own code to it. You could add more commands that the XDevApi can work with. And after we install the X plugin, which uses the X protocol, we need to use one of the connectors that supports the XDevApi. And through that connector, we can connect to the MySQL and work with that. Now, take note that the port here is different. It doesn't use the same port. It uses a different port, which is 33060. I know, very original. But that means that if you want, basically, you can use use both connectors and connect to the same database, just in different ports. Now, let's take a look a bit about different CRUD operations. We'll see also a bit of examples. If we want to do something in an SQL format, how we would do it, and what's the equivalent in the Node.js with XDevApi. So if we want to create a collection, I would use the DBA API and run the create collection. As seen here, I'm creating a collection called Meetup collections. If I want to see what collections I have inside the database, I would do it like that. If I want to drop them or get them, I would use the DB API, and then run the drop collection or get collections. Now, if I would want to insert a new document into the MySQL, if I would want to do it in the SQL format, I would have to run two different inserts, but with XDevApi, I could either do it, append one document to the other, or do two different commands, which just appends two documents, one after the other. Now, let's say I want to search something. Doing it with regular SQL, probably you're familiar with it. We'd use the where clause, and the condition is here. With XDevApi, I can also do it straightforward, or I can use parameters, bind variables. Now, as a rule of thumb, when working also with my regular SQL and with XDevApi, guys, always use bind variables. It's more efficient. It's more efficient in the way that if you want to run this query a couple of times, it will be a bit faster after the first time because the execution plan is already created. Then in the next time, it just has to change the parameters, not recalculate the whole execution plan. So try to always use bind variables and not do it in this format. Now, let's say I want to update a row or a document. If I would want to do it in an SQL format, here's the example. And if I want to modify a document, I would just use modify with the set. And here's the document stored. Now, if you take a look here, the ID, this is the ID that I talked before that is a unique ID for each document, where it also resides in the document and it also resides outside the JSON object in another column by itself, but in the same row. Here's an example if you want to delete a row or delete a document. Here if I'm using remove. Okay, now working with XDevApi, it's really similar to working in NoSQL fashion, but it has a couple of advantages that NoSQL does not have, such as working with transactions. As we see in this example here, we can, in XDevApi, we can start a transaction, add a new document, create save points. I can add more document, roll back to my save point, and then commit. So this is pretty flexible, as you can see. It's really nice not having to work with regular queries, regular DDLs or DMLs, whatever you need to use, and just working in this seamless fashion. I really like it. Hope you too. I hope you too. So before talking about how we think of implementing XDevApi here at Wix, first I need to explain to you how our database architecture works. Now, all of our servers are running on either Amazon or on Google. All of our MySQLs are community editions. We don't have any enterprise MySQL running at all. And in a regular MySQL cluster, a cluster can have a couple of different roles. Most of the nodes serve production purposes, and we also have nodes that serve BI, development, or even backups. Those are basically all the roles that we have. Now, in the screen in front of you, what you can see is basically two of our main data centers. DC1 is a mirror image of DC2. What we have here are the application servers that the connections go through Proxy SQL. If you're not familiar with Proxy SQL, I really suggest you go check it out. It's a great open source tool. Basically, Proxy SQL allows us to reroute MySQL connections depending upon query rules or a set of specifications we assigned. That way, the application only has one URL and only needs to take note of only one point. And in the background, from the MySQL, we can dynamically add more nodes, remove more nodes, and the application is oblivious to it. Everything is done through the Proxy SQL. Now, one thing that we utilize the Proxy SQLs for example, is we have a separation between our write connections and our read connections, meaning the Proxy SQL will sense if the application needs to do a write action, and it will redirect the connection to the MySQL that is open to writes. And if it needs to do a read action, if it needs to query something, it will redirect from one of the MySQL that is that has the appropriate role, in this case a production role, and can be read from. So what do we see here? Basically, we have a master replication between the MySQLs in the different DCs. And we have here two masters, where only one of them is open to writes, and the other one is read-only. And we have a MySQL slave under this in each DC. This is so we can have a horizontal scale for reads. Now, some of you are asking, okay, what? I'm guessing right now some of you are asking, okay, why does it look like this? Why aren't you using regular MySQL replication? And the answer for that is because here at Wix, we have a pretty special use case. a lot of times we will need to move traffic between one DC to the other. And what that means is that we'll have to initiate a switchover or a failover, where the traffic goes from DC1 to DC2 or vice versa. And the reason that we have this architecture is because changing the writers from DC1 to DC2 will, in fact, basically, we set read-only here and we set read-write here. It's really fast. It takes about 1 to 2 seconds to do it. And the proxy SQL automatically knows that there's been a change in the master that's open to write and will redirect connections accordingly. Now, if we would have done it with regular MySQL promotion, it would take in a bit more time. Regular MySQL promotion would have taken us from 30 seconds to 1 minute, which is pretty long. Now, take into account, we have a lot of MySQL clusters. We have more than 100 clusters. So we need to do this action for every one of them. Of course, this is automated. We have an automated backend that does this procedure for us. We don't do it manually. But still, it's pretty fast doing like this. And the application has less time receiving exceptions, whether it would have, if it would have done it with MySQL promotion. Okay, so this is what we have right now. I hope this is clear. So looking at this slide, we're thinking, okay, how can we implement XDevApi here at Wix, and how can it be easily implemented in this configuration? So I would like the proxy SQL to use it also with XDevApi. Unfortunately, proxy SQL does not support XDevApi. There is no plan to support XDevApi in the near future, and that's a real bummer. So basically, what we need to do, we need to think of something that will substitute the proxy SQL layer, that will be as good as it, and yet will also support XDevApi. So this is our challenge, guys. This is basically the question we were asking ourselves. Okay, so what are our options? Now, we saw with the new connectors a couple of improvements. If we look in the new MySQL connectors, very similar to Mongo drivers, they also support host lists, so you can append them a couple of MySQLs, one after the other, and they will pretty much see which one is the master, which one is slave, which one is open to write. And it's very similar way to work with Mongo. Now, here at Wix, as I mentioned before, we mostly work with Java and with Node.js. Now, the new connectors do support XDevApi. The Java connector is pretty advanced, it's pretty stable, it has a really good failover option. It also supports smart load balancing that it knows to query the slaves, the read-only slaves. Now, unfortunately, the Node.js, even though it does have a smart failover, its load balancing option is pretty primitive. The only way to work with it right now is basically just to set in advance inside the driver a priority, very similar to Mongo. You have to set, if I have like 3 nodes in the MySQL cluster, I would have to set a different priority, so the queries will be routed between the priorities. And this is not something that we're looking for. We're looking for something a bit more dynamic and also a bit more stable. So the Node.js MySQL connector is not a good option for us, although the Java is. Okay, so now looking at this, thinking about our options, one of our options is basically just play the wait game, wait until a new MySQL connector for Node.js will come out, and then our architecture will look something like this. where we eliminate the proxy SQL layer, and the applications connect directly to the MySQL clusters. And it's a similar architecture. If you're familiar with Mongo, it's basically a similar architecture to that. So that is one of our options. Now, if we don't wait for the Node.js, we also have another option that we are looking into. And in order to explain that option, we need to talk about two new products Oracle came out with. One of them is InnoDB Cluster, and the other one is MySQL Router. So InnoDB Cluster is a new type of cluster that has high availability out of the box. The cluster is aware of itself. It knows which one is the master. If one fails, it knows how to elect a new master in its place. It also has administrative API, which you can manage it with the API provided with it. And it's also really to add a new node to the cluster, where you just specify the new node, and it has an automatic cloning feature where it will copy the data from the closest host to the new host and add it to the cluster, which is really nice. And the MySQL router is something that is implemented. It's a lightweight middleware, basically, that lets you also load balance and failover connections, and supports also XDevApi. Now, the InnoDB cluster, together with the MySQL router, basically provides a virtual IP for the cluster. So for the outside world, they only have one IP, and internally, the MySQL router will route the connection to whatever relevant host. That means that if a write connection will only go to the master, and a read connection will only go for one of the replicas, for example. Of course, it has a couple of more features, but that's one of them. Looking at the InnoDB cluster, we do need to talk about the InnoDB cluster versus the regular MySQL application. InnoDB cluster, as I said before, has a selection for a new master. If you're talking about regular MySQL application, as I showed you before, you need to use a special infrastructure or script, or you could use also orchestrator that does automatic promotion. But the point is, it's not out of the box. The InnoDB cluster, as I mentioned before, is very easy to scale, has administrative API that you can manage it. And the regular MySQL application, basically, you have to work to make it. You have to do some work to make it work. It doesn't have any admin API. You have to use either InnoDB backup or copy the disk or some other method to add a new slave to the cluster. But looking at the bottom line, the regular MySQL application is a mature solution. It's what we use currently at Wix. It supports all of our load. It does a really good job. It hasn't failed us yet. And looking at the InnoDB cluster, it doesn't seem yet as a mature solution. It does look something really, really promising, but still it's a bit too early. I would hope that in the next minor releases, maybe it will be more stable, but right now it doesn't look very stable. Okay. Now, taking what I said about the MySQL router and InnoDB cluster, this is what it would look like. Let me explain what you're seeing here. So, as we have before, we have DC1, DC2. The circle here is an InnoDB cluster with MySQL router, where the MySQL router basically is a one IP to the outside and maps internally the connections to whatever is required, as I said before. So we have two InnoDB cluster with MySQL routers. Between them, we have a master application where only one of them is open to write and the other one is read-only. And the application has also MySQL router installed on it. The reason is because some of the drivers are not very mature. As I said, As I said before, that the Node.js is lacking good load balancing. So the MySQL will act as our failover and load balancing between these two connections of this InnoDB cluster and this InnoDB cluster. That way, they see all the cluster, and they can also work with XDevApi. So just briefly, I'll go over this again. The application has MySQL router. When the MySQL router is aware of both of these clusters, each of these clusters is an InnoDB cluster with MySQL replica. They have between them a master application, where only one of them is open to writes, and the other one is read-only. And the MySQL router is aware of both of them. With this architecture, it is possible to orchestrate MySQL regular connections, and also using XDevApi in our architecture. We are still thinking about implementing this, or just waiting a bit more until the Node.js driver will be good enough to use. But that's pretty much our other solution. Now, guys, a couple of things I want you to remember from my talk. XDevApi is a really nice feature that lets you work in a schemaless way with the MySQLs, basically letting developers work a bit easier, not having to worry about the database objects. And also, unfortunately, Practice SQL does not support XDevApi. I really wish it would. If it would, my problems would disappear, and I could just use Practice SQL with XDevApi, and some of the developers in Wix would be really happy. But unfortunately, that's not the case. And that's my talk. I hope you found it interesting. Stay tuned to Wix Engineering. Continue to give you more database administrative stuff.